Grade 11, graphs of functions, grade 11, mathematics paper 1. This is revision of functions. Let's have a look at this question. The diagram below shows the graph of f of x is equal to 1 over x plus 3 minus 1, and g of x is equal to half x. We are given here the graph of a hyperbola, and we are given a hyperbolic function and a linear function together. The graph are intercepting at the x-axis at a and b. That is the graph of f. F is intersecting the x-axis at a and the y-axis at b. The two graphs meet at point C and point D. And there are a couple of questions we need to answer. Number 1, write down the equations of the asymptotes of f. This is a straightforward question. Now, when requested to write down the equations of the asymptotes, the first asymptote, we equate y to the constant value. So in this case, y is equal to negative 1. We equate y to the constant value. That is the equation of the horizontal asymptote. The second asymptote, we equate the denominator to 0. So x plus 3 is equal to 0. This gives us x is equal to negative 3. These are the equations of the asymptotes of f. It is important to make sure that you express them as equations, because the question says, what are the equations? Sometimes learners write minus 1 and negative minus 3. Then in that case, you are expressing it in a wrong way. They are equations. Y is equal to minus 1 and x is equal to minus 3. Number 2, what is the domain of f? The domain of a hyperbola, always the domain of a hyperbola, x is a real number. So x is real, but we must express that the value of x cannot equal to the values of the asymptote. So x is real, but x is not equal to negative 3. This is the domain of our function. We can also say that x is an element of negative to positive infinity, but the value of x must not equal to negative 3, because x is equal to negative 3 is our asymptote. That's the domain of the function. Question number 3. Calculate the length of line OB. Now, for us to determine the length of the line from O to B, we need to know the coordinates of point B. B is the y-intercept of the graph of f, the y-intercept of the hyperbola. Now, this is another way of asking us to determine the coordinates of the x and y intercepts. So to determine the y-intercepts, we substitute x with 0. To determine the y-intercept, we substitute x with 0. Our equation is y is equal to x plus 3 minus 1. Then if we put 0 in place of x, this will give us 1 over 0 plus 3 minus 1. Then in simplified form, y is equal to minus 2 over 3. Then this gives us the coordinates of point B. The coordinates of point B are 0 and minus 2 over 3. Now that we know the coordinates of point B, which is the y-intercept of the function, we can also make a conclusion that the length from O to B is equal to 2 over 3 units. That is the length of the line. So we determine the length after calculating the coordinates of point B. Number 3.2, we want to find the length of line O to A. Now for this one, we need the coordinates of point A. A is the x-intercept of the graph. To determine the x-intercept, we equate y to 0. Y means the entire equation f of x is equal to 0. Then we solve it. Our f of x is 1 over x plus 3 minus 1. This is equal to 0. Then from there, we move or we transpose the negative 1 to the right-hand side, where it will become a positive 1 over 1. Then we cross multiply. This will give us x plus 3 is equal to 1. And we move the 3 to the right hand side. It will give us x is equal to 1 minus 3, which is equal to negative 2. Now, therefore, the coordinates of point A, which is the x-intercept of f, is minus 2 and 0. Now, after that, we can be able to determine how many units are there from point O to point A. So in our graph, we can see that since point A is 2 units, is negative 2, 0, it means OA is equal to 2 units. That answers our question. We have answered our question 1. We have answered question 2. We also have answered question 3. So OB, let me just write here, is equal to 2 over 3 units, and OA is equal to 2 units. Now, very much important, when you are doing maths and you are going through past examination papers, revising and preparing for your examinations, you need to ask yourself, what is this question teaching me? After answering it, you must ask yourself, what did I learn, or what did this question remind me? In this case, number 1, we must always know how to express the equations of the asymptotes of the hyperbola. Number 2, we must know how to write down the domain and range of a hyperbola for any function for that matter, but we are just specifying according to this question. Then question number 3, we must know how to determine the x and y intercepts of a graph. To find x, y is 0. To find y, x is 0. So in that case, we are able to then answer a new question, because once you know the concepts, then we can be able to apply them even in a new situation. Let's do question number 4. Now we need to find the coordinates of point D and the coordinates of point C. Now, the idea that is needed to answer that question is when two graphs are crossing each other, they are equal at the points of intersection. So my graphs are crossing each other at point C and point D. To determine the coordinates of the points where graphs meet, we equate the equations of the graphs and solve for x. So in my case, f of x is equal to 1 over x plus 3 minus 1. This is equal to g of x, which is half of x. Now I need to solve this equation to determine the values of x. I have fractions here. When you are working with an equation that has got fractions, you can get rid of the fractions by multiplying the equation with a common denominator. So my denominators are 2 and x plus 3. So I'm going to multiply the entire equation with 2 and x plus 3. Why am I doing this? Because I want to get rid of the fractions which are in the equation. So once again, to remove fractions in an equation, you multiply the equation by a common denominator. So my denominators are 2 and x plus 3. I put x plus 3 in brackets and multiply by 2. That becomes my common denominator, or the lowest common denominator. So this x plus 3 and x plus 3, they cancel. So 2 times 1 gives me 2 as my first term. Then 1, there is a negative 1 here. We're also going to multiply it by those two numbers. I'm going to write negative 1 times 2, then multiply it by x plus 3. Then on my right hand side, the 2 and the 2 can be divided. So we are left with x multiplied by x plus 3. Now I need to simplify this equation until it is in its simplest form. Negative 2 there, this is a minus. We are solving a simple equation, basic algebraic calculations that we should be knowing. If we have forgotten them, then we can remind each other. Negative 2 times x, it will give us minus 2x. A negative 2 times positive 3 will give us minus 6. This is equal. Then x times x, it will give us x squared. And x times 3, it will give us a plus 3x. This is our equation. We have x squared. So if you have x squared in an equation, it means it is a quadratic equation. The golden rule for a quadratic equation is that you must make sure your equation is in a standard form. So I transpose the 2 to the right hand side. It becomes positive 2x plus the 3x. That gave me the 5x. I have 2 minus 6, that's minus 4. If I move that minus 4 to one side, it's going to become a positive 4. Then I remain with the 0 on one side. So what am I doing here? I am simplifying my equation until it reaches standard form. Now, once the equation is in standard form, I can solve it by factorization, by completing the square, by any method that I am comfortable with. So in this case, we can factorize into x plus 4, factor of x plus 1. This will be equal to 0. Then the first bracket gives me one solution. X is equal to negative 4. And the other bracket gives me another solution. X is equal to negative 1. Now I have got my two values of x. I must choose which one is for C and which one is for D. D is on the far left, therefore the value of x there can only be the smaller one, which is negative 4. So to calculate the value of y, we use one of the two equations, the equation of f or the equation of g. To save time, use the simpler equation. Y is equal to half x, the equation of g. Then in this equation, we put minus 4 in place of x. This will give us y is equal to half of negative 4. That's minus 2. It means the coordinates of point D are minus 4 and minus 2. Then the coordinates of point C are in the same way. Y is equal to half x. In place of x, this time we're going to substitute x with negative 1. That will give us y is equal to 1 over 2 times x, which is times negative 1. And it gives us y is equal to minus 1 over 2. Now we can say, therefore, the coordinates of point C are going to be the x value is negative 1 and the y value is a negative 1 over 2. We have determined the coordinates of point C and the coordinates of point D. The idea is that when two graphs are crossing each other, we can find the coordinates of the points where they meet by equating the equations of the graphs and solving for x. It's a kind of simultaneous equations that you are solving. You solve the graph of f and g simultaneously to determine the coordinates of the points where the graphs meet. The last part of the question, that's question number 5. In general, when you reach the bottom part of the questions, the calculations that you are going to do there are connected or related to the previous calculation that you have already done. Because each time you work out something, you get the answer. That answer becomes part of the information that you may need to do more calculations. Now, let's have a look at question number 5. We want to find the values of x for which 1 over x plus 3 is greater than or equal to x plus 2 divided by 2. And the question says that we must use graphs to answer this question. Now, if you look at the equations of our graphs and what we have here, there is a little bit of some connection. F of x is 1 over x plus 3, and then g of x is 1 over 2x. We can rewrite this expression and make sure that the expression looks like the equations we have. So on my right hand side, on my left is 1 over x plus 3. Then this is greater than or equal to. We have got a fraction here. Fractions can be added if the denominators are the same. That allows us to separate this fraction into two different fractions. X over 2 plus 2 divided by 2. And 2 divided by 2 is 1. So this is now 1 over x plus 3 is greater than or equal to half of x from the first fraction plus 1. Now look at how cute this is. If you move this 1 to the left side, it's going to be a negative 1. So on your left, we have got x plus 3 minus 1 is greater than or equal to 1 over 2x. That is what I have in simplified form. Then going further, we can see that if you look at this expression that we need to determine now in relation to the equations of our functions, the equation I have on my left side, that is the equation of f of x. Then the equation I have on my right hand side, that is the equation of g of x. So in other words, the question is asking for values of x for which f of x is greater than or equal to g of x. Now, this kind of questions, the answers are determined by the x-intercepts. So we need our answer to the coordinates of point C. We calculated that one, particularly the x-coordinate. We need the x-coordinate of point C, that's minus 1. We also need the x-coordinate of point D, that's minus 4. Right, so this is the x-coordinate of point D. It means on the x-axis that point is negative 4. Then this one on the x-axis that point is negative 1. At the points where the graphs meet, the graphs are equal. F of x is equal to g of x. But once they cross each other, one graph becomes smaller than the other. So if I say f of x is greater than g of x, I am looking for sections where the graph of f is on top of the graph of g. So in my case, it's from the left side up to point D. I can see that the graph of f is on top and the graph of g is at the bottom. Once we cross G, the graph of f is now below the graph of G. So my answer is from the left side up to point D. Then let's look at point C. We also notice that from the asymptote given right through until point C, the graph of f is also on top and the graph of G is at the bottom. Once we cross f going to the right hand side, the graph of f is now at the bottom. So the answers for question number 5 are as follows. X is equal to from negative infinity up to point D, and the x value of point D is minus 4. Then the other one is from the asymptote from the vertical asymptote up to point C. The vertical asymptote has equation x is equal to -3. So that means from -3 up to the x coordinate of point C, which is -1. Between -3 and -1, the graph of f is on top, the graph of g is at the bottom. Therefore, f of x is greater than g of x. I'm going to now have -3 up to -1. Important also to notice here is brackets. If you are given less than or equal to, then our brackets must be square brackets to show inclusion. So on the side of 4, I must have square brackets. -3 to 1, I also need to put square brackets. So that is the answer for question number 5. Quite a trick one, but if you analyze the question you are working with in relation to what you have been given, you should be able to figure out the relationship and therefore be able to read the answer from the graphs. This answers this whole particular question. Again, important is, what do you learn from this question? If you answer an examination question, you should go back to what did I remember answering this question, because you must learn ideas. The question itself may not be repeated, but the ideas will be the same. In question number 4, we learned that to calculate the coordinates of the points where graphs meet, we equate the equations of the graphs and solve them simultaneously. Then number 5, f of x is bigger or equal to g of x, means the graph of f is on top of the graph of g. The other things that we have calculated in question 1, 2, 3, the x-intercepts, how to read the equations of the asymptotes of the function. We need to be able to remember all those things. So that answers our question, graphs of functions, grade 11, mathematics, paper 1.